So there's my periodic table. And what I did is I showed the valence electrons. And so, for example, the alkaline metals have one valence electron. Alkaline earth metals have two. Transition metals all have two valence electrons. We're talking about valence, the outermost electrons. So these all have two, but as they go, they're filling with more electrons, but they're going to the inner electrons. They're inside the atom, and so it stays with two on the outside. But how it reacts is different because that inner level can interact along with the valence electrons. So that's transition metals. And then 3, 4, 5, all the way up to 8 as we go across the periodic table. So what they do is they form ions. Right here, from here over, this is metals. And here we've got our nonmetals. So nonmetals are gaining electrons, which is why they become negatively charged. And as they gain these, like this one gains 2, they become like the closest noble gas. So they get that stable noble gas configuration. The noble gases are like the cool kids of the periodic table. They are stable, and so the other atoms tend to make their electrons like them when they react. Now on this side, so these become negative ions. On this side, they lose their electrons. So metals and so they're going back and becoming like the noble gas by losing electrons. And so like beryllium loses 2, becomes a +2 ion. And so when they lose electrons, they become positive. And so all these lose and become like neon or like argon as they lose electrons. And all of these gain and become negative ions. But they're trying to get to that noble gas electron configuration. Nice stable electrons. And so that's why most of the atoms that we encounter in our body, that's moving around in our body or in plants, they want ions. They want charged particles that interact and work. And so that's why we talk about ions and why they're important. So there we go, a little bit of electrons, electricity, how the periodic table is set up based on valence electrons and why they become ions. So that's our message for today. Hope you have a great rest of the day.